We're going to review a little bit about shape of data. And I know we looked at this in the classroom before we were dismissed for this virus. So I just want to take a second and go back over it because I'm going to give you an assignment about it and also about dot plot. So this will cover both things. All right, so the little saying we said about shape of data is that you follow the tail of the whale. You have three choices as a sixth grader as the shape of the data, or sometimes it's called the distribution of the data. And that's either skewed to the left, skewed to the right, or symmetrical. So, Miss Kelly Lee from the high school, with all her wisdom, came up with the little saying of follow the tail of the whale. Now, what she meant, change color so it looks different, is that you sort of draw and you can sort of see that whale there. You have to have a little bit of imagination, but you can see that whale, and right there is the tail. So the tail is to the right, so we would say that this data is skewed to the right. Now, remember we talked in class that you would not draw over it like this. I mean, you sort of see a tail even if you do that, but the correct way to do this is that you go to the highest point and slope down. And so there again, you see that tail there. And that tail is to the right, so it is skewed to the right. This set of data, start here, work your way up to the highest point, which is there. And then you slope down back to the lowest point. And this one actually looks like it has two tails. And this is what we would call symmetrical. And it's not perfect symmetrical, not at all. But out of my three choices, skewed to the left or skewed to the right or symmetrical, that is the best choice. And it's very, very difficult to get a perfect symmetrical piece of data. Though I think I have an example in this in a moment, but I think it was man-made and not just random data taken. And so here we have another piece of data about number of siblings. We did something like this in the classroom. We go to the highest point, and then we slope down to the lowest point. And again, you can see the tail here is to the right. So we would say this is skewed to the right. Okay, here we would slope up to the highest point, which the highest point is actually the 4 and 6. And then we would slope back down. And again, this one is super close to being symmetrical. If it had these right here, it would be perfectly symmetrical. But we would call this symmetrical. And that one you can see, you sort of begin to see it without even having to draw. You see that that one would be skewed to the right. See if I did this. There it is. There's another one. Hopefully you can see that it is skewed to the right. Here's one to the highest point, down the lowest. At this one, the first time, our tail is to the left. So we would say this is skewed to the left. There's another skew to the right. Another skew to the right. Now this one is one that could probably get some people in trouble because they would want to do this. And we don't do that. We go up to the highest point, which is right there. at the beginning. And then we move down. And that one's a little harder to see, but there is a tail there. And so that would be skewed to the right. Here's the one that I said was the perfect symmetrical. That is your perfect symmetrical. Well, can't write today. Here's you go to your highest point. Swap down. This one is your skew to the left. Think about that one for just a second before I tell it. What do you have in your head? And this would be skew to the right. There would be our tail. Think about that one for a sec. And again, and we've had, in past years, we have had discussions about this one. And if we were in class together, we would discuss this one. That some people will argue it is symmetrical. And some people will argue it is skewed to the left. And you would have to make your reasoning for your argument. And you could argue it possibly both ways. I seem to tend, as you can see how I drew it, seem to tend it is skewed to the right, skewed to the right, but it's not a large skew. I will agree to that it's not a large skew like that one, or there was one that one is a large skew. That one, of course, there's some outliers in this one. So let's take a minute and talk about that there's some outliers here. And we've talked about outliers and things like that and how outliers affect your data. If there was not, remember when we did our dot plot in class, when we did our ages, Miss Pendleton was the outlier. So if we took these outliers out, this would definitely be symmetrical. So outliers affect your shape. Outliers, remember, can affect your mean. Outliers have more effect on your mean than outliers have effect on your median. And we're just going to use this graph right here, this dot plot, to emphasize that again. So if I gave you this dot plot and I asked you to find the mean, the median, the mode, and the range. Well, the range is super easy to see because one great thing about a dot plot is your numbers are already placed in order. So you know your range is going to be 10, subtract 0, so your range is 10. Another great thing about dot plots is that the mode is real easy to see because it's the tallest column. So your mode is 2. Now, I always wait and do the median last, and we've discussed that and why I do that. So we're going to go skip back up and do the mean. So I have 4 zeros. 4 zeros make 0. I have 1, 2, 3, 4, 5, 1. So that's a total of 5. I have 6, 7, 8 twos, which is a total of 16. I have 4 threes, which is a total of 12. 2 fours, which is 8. 1 5, which is 5. 1 8, which is 8, and 1 10, which is 10. So if I wanted to find the mean, I could add 0 plus 5 plus 16 plus 12 plus 8 plus 5. And I didn't make that very neat at all. So I have 0 plus 5 plus 16 plus 12 plus 8 plus 5 plus 8 plus 10. So if I add those together, that would give me a total I got 64. I want to add that again to make that is very not neat. Grammar's going bad at being home, isn't it? And I got 64 again. Now, I'm going to divide that 64 by how many dots literally are on this dot plot. So there was 4 and 5 make 9. And then there were 8. 9 and 8 is 17. 16, 9 and 8, 17. 18, 19, 20, 21, 22, 23, 24, 25, 26. So let's count it again. 1, 2, 3, 4, 5, 6, 7, 8, 9. 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. So you divide that by 26 because there's 26 pieces of data. And that's not going to come out pretty, I can tell you, before I place this in the calculator. So I would round that to 2.5. Now, there was 26 pieces. That's an odd amount. Half of 26 is 13. So my 13th and 14th piece of data are going to be my 2 in the middle. So we're going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right there would be my median. Since they're both 2s, my median would be 2. Now, that is with all the data. Now, let's talk about what would the mean be if we took out the outliers. Okay, if we took out the outliers, that would change my total to 46. That would also change the number of pieces of data to 24. And 46 divided by 24, that changes my mean to 1.9. Now, I know that's not a huge difference, but you're only dealing with numbers 0 through 10 anyway. Now, if I take those two out, that makes me have 24 pieces, which we said. And half of 24 is 12. And so my 12th and 13th number would be in the middle. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Does my median change? No, my median doesn't change. So outliers affect your mean always, either increasing it or decreasing it. But it doesn't always have to affect your median. And we proved that with the little family activity we did with Grandpa Charlie and mom and dad and the kids, that a lot of times the median did not change, but the mean would always change if you changed any numbers in your data set. All right, so if you have any questions, please email me. Please Google Hangout with me or whatever you need to do to contact me if you have any questions about this. Stay safe, stay healthy. Bye, guys.